Hi guys, good afternoon. Welcome back to our channel. If you have not subscribed yet, so do please subscribe and don't forget to hit the bell button so you will be notified for our very exciting and more topics, more tutorials and real application that we will be creating soon. So this afternoon guys, uh, I will demonstrate in a .NET 7 application. So we are using .NET 7 framework now, and then we are creating a web API, a controller base, and then going to implement. We are going to implement, uh, a repository pattern. It's not just a repository pattern, but it's a generic repository pattern. And also we will show you how to implement a unit of work, and of course how the dependency injection is being done or being configured in .NET 7. So as you can see my screen guys, I already created this um, application. This is .NET 7. If you can see, the project name is VRF web API. So I'm going to have a project for the business request form. So it's not finalized yet. So I just created I just created the design of the database and also the API, because this will be exposed in API and will be consumed in, I don't know if whether Power Apps or Angular, but if the front end will be assigned to me as well, I will be use Angular. So what's for the next video? We will be using Angular 15 for our front end in this back end services web API. So you can see here the target framework is .NET 7 already. And if you have not familiar with .NET 7, there are lots of new features such as implicit using. So if you enable this in your main program, even if you will not include the explicit using system, you can use the console.write line. So it will not require. For here, for example, this is your program. You can just easily say console, so it will not. It's already available, and some other as well. So you can see I can use the console without using the system, right? So that's one thing. So guys, as I said, we're gonna talk about the repository pattern and the generic repository pattern, as well as the unit of work, how it goes. So first, the dependency or packages that I already installed that allow us to use for this application, I just going to walk through because this is already done, but it's partially done because this is not the whole application yet. Okay, so of course, SP.NET Core Open API, that's Swagger, that will fire up or we will use to test our endpoint. And then we have to install the package entity frameworks that Sql Server is 7.0 now. And of course, the Microsoft Entity Framework for that tools. So you can have issue the command add migration, update database like that. So for example, if you already have these models and you have your connection here, this is our VRF DB connection, and we inherit the DB context which is coming from EntityFrameworkCore. And in our constructor here, we just pass it to this option, which is it's going in the this class, which is the EntityFrameworkCore. And this is your entity that we define already. Then, of course, we have our entities already defined here. Yeah, so to actually create that database in your SQL Server, because you're using SQL Server here. For example, this is my SQL Server, as you can see. And then the database is not existing yet because this is code first approach, meaning we are going to create the database including its table, entities, table columns like that after a migration. So I think I did the migration before, but this one is not. I just deleted the database, so I can delete this migration table and do it again, so you can follow me how you are going to create the migration. All right. So first, we should set our connection string. That is why I put it in here in app setting.json file. So this is my data source. This is my local server in SQL Express, and my initial catalog VRF app DB is not existing yet. Okay, so as you can see here, there's no app catalog DB yet. So that is why we are going to issue a migration to create its database. So integrated security, I just pass it through. And EntityFrameworkCore 7, it has a new feature also that the trusted certificate, I mean the issued required, I mean the encrypt is by default equals true. So it means to say that by default you have is a certificate is required. So how we are going to bypass that if we are not creating our this is a certificate on our database, we can just issue this trusted certificate equals true. So that is how to bypass. If you omit this guys, you cannot create the migration. It will give you an error. So for example, I will delete this and we will create a migration. So let's say what's the error that we can get, right? So we go to our new git package, my git package console, and then this is the one that I created just previously. So where is that? We create our migration. So yeah, I just have to install. No, migration is the command is add underscore migration. It will create a migration folder, and also the definition of our files entity. Then just name it update db. Right, when you click that insert that, yeah, it's create a migration, but it will not create a database. So you can see here there's a migration folder, and the name is update db. And then of course this is the being definition. So this is the entities that we define in our code, and this will be created in our database when we issue the command update db. So from update database from here update database, but I said this will not be successful because of the certificate issue. So let's take a look. Update database. Oh, it succeeded, but this is the one that I'm talking about. The connection was successfully established with our server, but then an error occurred during the login process. So provider SQL Server error 0, so certificate change was issued by an authority that is not trusted. So if you can see in our SQL Server here guys, even if you press it, there is no database that's been created because of their problem. So that is why, that is EntityFrameworkCore 7, that by default it required you to have a certificate, SSL certificate. So if we have not installed it, so we need to bypass it in our connection string. That is what I'm talking about here. So we can just undo this and we put this trusted certificate equals true. That is to bypass that. Alright, so we save it and let's create update database again. And this will work. And you see it? There's no error. It's not done yet. Okay, it's done, so it's created. So that's the only thing that new changes that we actually there are lots, but we can use the other feature in the upcoming videos. So that's one thing for now. Okay, so when you refresh this database, you can have now your database is created. We are up DB. So you just supply your connection string and update migration, update database, and it will create your database. So the tables that I define here, this one, which is in our code. So that is code first approach. All right, so we have now our database. I think we are ready to go further. We will talk about the repository pattern that we use this. All right, so we just close this. Okay, so these are the models, and this is our connection string. So basically, we just define the entities here, and of course the connection. And then of course, first thing in our program.cs file, this is where we add our DBs. We configure our services and middleware. This is the middleware, which means to say it will act as a bridge to our ORM. So DB context is passing our connection string class, and then since we are using SQL Server, so we use SQL Server, then we get our connection string. So builder.configuration, that connection string, this is the name of our connection string, right? So this is one thing. You have to configure your services first, sir. Okay. And then the next thing is that we are going now to actually, this is just a very simple application. We are not using really clean architecture, but it's somehow clean already. We just separated it by folder. But this is just one component of our project. So this is the endpoint only, the web API that talk to our database. So our client application cannot interact directly to our SQL Server database. Okay, so first I created this interface here. So what is the first interface that I created if I walk through, if I have not done it yet? Of course, generic repository. Okay, okay, I will discuss about the benefits of a repository pattern. Number one, if you even research or Google it, number one is just to centralize your data logic or the business logic of your application. Centralized meaning you are not going to scatter all of your, for example, you add the database and then you save, and then another class you add to your database and then you save. So you have to put it in one layer. So when you call save or you have to add database, it's just one call, it's just in one class. And another one is that it can give you a substitution part of the unit test. So if you're into TDD, test driven development, that's also benefits of repository pattern. And number three is that it provides flexible architecture. Why we can see flexible architecture? Of course, for example, today you are using SQL Server, but tomorrow or next month or next month you will be using another database. So you don't have to change anything in your client application. I think you are just going to need to change in your data source or in your data like this logic inside your repository that will connect to your what kind of database you are going to use. All right, so if you modify the data access or business logic layer, then there's no need to change the repository logic, right? So, and then that's just one thing, the benefit of repository. However, if you combine it with the generic repository, the more advantages that we can get. Because of course, the benefits, number one benefits of generic repository, guys, is that it will reduce redundancy of code. Why? For example, this one, if this is a repository, not generic, so you cannot pass a type of entity here. So in our implementation, for example here, this is the implementation of our generic repository, this one, okay? So these are all repository, which is to say, its entities will have its class to save, to add, or to remove to your ORM, right? So by that way, because we are creating generic repository, we can add any entities here. For example, what are our entities here? We have TVL request. You can just pass it. Or if you're going to use the request division, you just have to pass it, and you are not going to create another class that will act as your repository. So that is, we reduce the code redundancy. So one principle of object-oriented programming is DRY, D-R-Y. Okay? Don't repeat yourself. Because if you keep on repeating, of course, there are lots of errors, prone errors, because there are a lot of codes that is being repeated. So don't forget DRY. Don't repeat yourself. And then, of course, that's abstraction. So you are keeping your logic, data access logic away from your application or the front end or the business logic itself, right? So it forces also your other developers, especially if you are in a big project and lots of developers, it forces to work with the same pattern. So other developers will not define his another repository pattern because you have centralized it. Okay, so they will be forced to use one single repository pattern. And of course, I have mentioned it already, is least prone error possibility. And of course, it's an easy to maintain data access logic. Okay, and then why we should have a unit of work, right? So as you can see here, I have this interface unit of work. And this one, I only have save assign. So if you go to our generic implementation of the repository of unit of work, which is unit of work class, it's only have, aside from the dispose of course, save async is only written here. Okay, right? So if you are not going to use a unit of work, you can have another many methods of how to save in different repository or your generic repository. For example, in our generic repository here, we can have save here because there's no way to save it actually to our database. So even if this is generic, it will be repeated and repeated. But the main goal, the main advantage of unit of work or what is its use is it is used to aggregate multiple operation into a single transaction. So many transaction, it will be considered as one transaction. So it will ensure that all of the operation will either be succeed or failed as a unit. All right. So we can tackle it later. So I will show you some of real application of that. But let me proceed it with me proceed in navigating or in how I implement it. Okay. So first I created just an interface. So first thing that we have to define is of course after we are able to connect to our database, we create generic interface for repository. So this generic repository, that's why we pass here a generic T entity. You can name any variable here, T or whatever. So I just put it T entity. And I also limit this, that this class will only have a class type. This is why T entity is class. This is how to be limit type that cannot inherit this interface. So we have T entity for getting a single query. We have an enumerable of get all, unless enumerable we can have the expression func here where the predicates. So you have to query with where condition, and of course you can also have asynchronous like that. So these are the generic repository that we define. Of course you can add more. And then how we, and this is interface, so we have to implement it. The concrete class here is this one, generic repository. So generic repository of type generic, of course, we inherit the interface generic repository. So when you inherit that, it will automatically implement, or if you are not going to implement it, it will have an error, so you are going to implement it. Implement, which is this is the actual implementation. Okay, and then in our constructor we just add inject, or this is the dependency injection. So we add the our connection, of course, this the underscore context. Okay, and then we use that connection variable. So that is why that context that set the entity. If you pass this what entity is served, then it will add. Yeah, so it's something like that, but there is no saving it yet to the actual database. So something like that, guys. So everything is being implemented here now. Now, as you see, for example, this table request, this is the entity. If we are going to add this, as you can see here, we also include the navigation property here. So what does navigation property? It's just like a relationship in our traditional SQL Server. So for example, this table request is being linked to a table request type, a list of table request type, and table request division, table request impact. So it's just one to many, or there's just a relationship. So if you are going to add this, you are going to save to the TBL request, TBL request type, TBL request division. If we are not going to use unit of work, it may be it will save to the table request, but it will not save to other tables. So you cannot, I meant there is already a data integrity failure there, because you are saving to this one table, but the other table is not saving. What if in the second table only it will throw an error? So what happened is, because we have unit of work, so if there's an error for every one of that entities, then it will be rolled back, because it will be saved as a single unit per transaction, right? So this is the unit of work. So now, if we try to look our interface unit of work, it's basically only, of course, this one is identifiers of request repository. We'll discuss it later. So only we have save async, and the implementation of that is unit of work here is just saving to our your database. Okay. All right. So now we'll go to how we implement it, so it will be understand further. For example, this class I created interface here. This is for saving entities for TBL requests. So I name it TBL request repository, and I inherit generic repository of type entity TB request. All right. So I'm passing here TBL request. Now, aside from the signature that is already in our generic repository, I add two signature here: a get up BRE and get request by pins. So these are the signature that is specific to this class, TBL generic repository. But of course, it will have all other the signature coming from our generic repository. So how we implement it? The concrete class, the implementation. This is in our repository folder here. This is TBL request repository. So as you can see, we implement only the specific signature that we added into the TBL request repository. So this one, get request by feeds, we pass the feeds index and the feed size, and it will just return the context, the table request. How can we, maybe you ask, how can we access that context? Because it's being passed here. But in our generic repository, the context here is already public, this one. That is why we can access it. All right. If you are going to make this private, you cannot access it from here. I mean, the implementation, where is that? Is this one? You cannot access it, right? So this is one thing. Okay, guys, in the client, how we are going to use it? since this is a web API, so but of course, before we go to how we call it from the client side or the API side, because we already have the unit of work here, in the program that says, we will add also the or configure the services a unit of work, because we will not call directly our BRF app DB context now. What we are going to use from our controller API methods is the unit of work already. Okay, so this is only used in our unit of work classes, but in our class implementation in the controller base, we will see it later. We will not use that directly, right? So that is why we configure here. We use add scope, so we can have add transient, add singleton. When we say add singleton, it's just like a global variable that every request is have one instant every request, but we don't like it. Add scope, it's like just like a local variable that in every request it has an instant, and it will lose, or another request it will create another instance, something like that. I don't know if I I discuss it clearly, but you can search it. What's the difference of that services life cycle? Okay, guys. So after we register that, this is how we configure our dependency injection here. Then in our controller here, we created a request controller, this one. So basically, we inject now. So you are in the constructor part, we do not inject the DB context class, but the unit of work. That is why our unit of work, and then the variable is underscores UOW. So that's now our unit of work. So for example, if we list all our request data, for example, in our SQL server here, the request, table request here, if we select it here, oh my god, this is why it's error. I think I just have to refresh this, and let's take a look. Request here. Failed to retrieve data for this request. An exception while executing your bots. Connection is broken. Maybe I restart this again. Okay, so we can see our system in table request. So you can see that, guys, there's no recursive. Okay, so we need to add that. So for example here, we have add method here, is this one. So it's a synchronous method. So add, this is the model. So we just check if model state is valid, then we can add. So unit of work dot request dot add. Then you just pass the model. And then unit of work dot save async. Okay. We'll try this one. We fire it, and the Swagger will have it. The Swagger UI. So we are not using Postman, we are using Swagger. So this is the add request. Okay. Let's take a look. We try it out. So as you can see here, we don't include ID because ID is identity. It will add by itself. So later on, we can apply also the auto mapper, so that what fields of your entities that you'd like to have here, you can just map it. Now, for example, you type your description in your request, and then other things, you just leave it blank. So you can see here, guys, this is another table. For example, TBL request status. Okay, if I put here 1, and let's say the status is waiting. This will add to another table. So as you can see right here, this is the table request status. There's no data yet. Okay. So I execute it, and of course we are debugging it. Okay. So you can see request add model. If we go there, it's generic, so it's being add here, or it's being what is being passed here is the TBL or the TBL request entity, and context that set TBL request entity. If you are going to have a class that, for example, another table, you just have to reuse the generic repository and then pass the entities like that. So you are not going to another class for your repository to add or like that or save to the database. All right. And then this is it's already added to our memory, but it's not actually saved to our SQL Server. So if you can see here, there is no data yet in our database. So to actually save it to our SQL Server, we just have to save it async. So this save async will actually save to our data. So we just go further. Then yeah, so that's it. It will save to what table? All of the table that is, of course, this one, because this is part of the request. So if you can see here, why this not data hit? Let me go back. Why it's not saving? Where is that? The request external error. So we have problem. Cannot insert explicit value for identity column in table request status. With identity insert is set to O. So the problem in table status. So we'll take a look. What's the problem in table status? Try again. You just clear this one, let's try again. No. This just skip and will not use the table status. Figure it out after this video. So request is here. Uh, let's say we will not update this. Just execute. Let's try it. It's working. Okay, it's working now. So problem with that. Okay, we have got success, and then if we try to look in our SQL Server, actually have now a data new request that is being added. So ID is 2. And we try to look to other table as well. For example, this one. It's now have also a data. And in other, it's also have a data. In other, it's also have data. So have you seen that and earlier it has an error. So it should not save to, or it should save to one table and the other table will have error. But because we are using a centralized or a unit of work which serve as a single unit in one transaction, that is why it's either succeed or fail. If the one is succeed, it will roll back. So it's saving in one table and then in the second table, it's failed, so it will roll back the first table that is being succeeded. So that is how unit of work is very the advantages of unit of work. So if we query now, we already have query list. So if we query, we can also get it. So see, we have one data. Okay. And then let's close this one and we'll walk through another code. So here in the controller, this is your API. So of course, route is API controller, so that's why API request. And then here list, so API request list, so it will give you a list. So you just have unit of work request that get on. So yeah, that's beauty. So you cannot just say, although you can see here that you can say like that var, you will not use a unit of work, you can just directly save to our database. You can say, where is the control is using something like that, var, for example, entities equals new vrif is that is, yeah, this is available. Vrif entities, yeah, you can have like that. Then entities that add, or entities that what table you are going to use request, yeah, DBL request like that. Then add, then what you're going to add. This is not the add list. Yeah, something like that. But this code will scattered all over in our API controller, because in every method you will do this one, right? So that is why we centralize it. So our saving or adding to the uh, memory, our repository is just here as a generic repository like this, and it is generic. And when we actually save to the database, so it will be in the unit of work. We are calling this. This is only one method and it's being used everywhere. Even what type of entities, how many entities you will use it. Right? That is good. A very good implementation of drive principle. Right? Drive principle. Don't repeat yourself, or else you will have lots of if you misplace one code, a lot of changes that you are going to done or to do. Right? So by the way, I forgot that we have created the table request repository, and then we just inherit the iGeneric repository, passing the table request entity. If you have no specific signature, this will be blank because you already have all the signature for the generic repository. And after you create this, or after you create this interface, you have to add that in your unit of work interface, this one. This is an interface repository request. And then when we going to implement it in our generic repository, of course, you will have that. And this is not the one. You implement the unit of work, you will have to implement that one. That is why we have here the request, which is of type interface repository. And the implementation, the concrete class is this one, table request repository, and we are passing the connection string variable here. That is why in our table request repository here, everything, I mean, the specific you have to implement here, but all the signature that's already in the generic repository, you are not going to implement here, right? So that is how it works. So first thing, I repeat, after you are creating your connection string, you have to register your DB context here, and then of course you have to create our generic interface here, and then you are going to create your unit of work here, which now include the ITBL request repository interface. Okay, so for example, if we are going to add, although this part, because our TBL requests already have navigation properties here, as you can see, if we add a data in your request, it's also add records in our other tables here. But for example, we're gonna have a separate endpoint for the entities. For example, the table request type. So we will create that. Okay, the simple description like that. Okay. So first thing that you have to do, we are going to go to our interface and we'll add an interface for that. Okay, we have to create a class, and that will be type interface. And by convention, we just follow what I have started here. So that will be interface TBL. What's the name of the table that I'm going to create is TBL request type. So it will be request type, or you can name anything you want. But by convention, this is what I use. Okay. So after you create this one, just like in the field, I will just delete this because in my previous one I use underscore repository. So by naming convention, I have to follow this. Okay. So let's create again class, and that will be interface. So it will be a request type underscore repository like that. And then this one, you will inherit the I generic repository, and you pass the type. The type that you're going for the entity is request type. This one. Okay, you can limit it. So after you have created this, before you implement the concrete class, you have to add this interface type in your unit of work interface from here. Okay, so you just have to add it, and you can name it as, for example, request type. This is only get. You just have to get it. After that, when you go to your implementation here and the generic, yeah, this the unit of work here is complaining because we add. So you have to also to implement your concrete class. So you have to add the signature, implement it. So that is why we have now interface type here, request type, and there's no implementation. So in the way that you are going to implement it, you have to create the concrete class for that. So just like this one, you have the concrete class that it inherit the generic repository and also the interface. So we will create the repository. We just name it by convention. It will be TBL request type repository. That, and this one will inherit the generic repository. Generic repository, and you pass the entity, it is TBL request type, as well as it will inherit the I generic, right? So let's try to look what I did here. Generic repository. And then of course the interface. That's why it's wrong here because we are passing the interface, not the entity. That's why it's mislead. This is request type. So this one, this is the OC. The entity itself. That one. And then we inherit also the interface I generic repository. The interface for this. So by convention we just I like that. So this is the class. So this is complaining now. You are going to implement. This is wrong. What is the interface I develop? This type repository versus underscores. This is the one that we need to inherit from our concrete class TBL request repository. Right? So now I'm going to implement it. So this constructor, it will just basically pass your connection string to, yeah, this is PRIP and we inherit it. Just like here, passing it anymore here. And this is the interface. So it's repository. Okay. So yeah, this is our PRIP connection string class. So we just pass it. And since we don't have any specific signature for that, so you don't have implementation here. After that, guys, so there's no coding, right? But you can add, remove, delete. Where is that happening? It is in your generic repository. And yeah, generic repository. So that's nice. So I hope you can see that, that one. Okay, so we go back to our this one. TBL repository. I mean, uh, request type. I know the unit of work here because we have not implemented it here. So now this one we just implement the request type. We will implement that the concrete class to be used here is TBL, the one that we created, TBL request type repository, TBL type repository. And of course, since we have a constructor that will accept the connection string, we add here the variable for that. This connection string. Hero, the name of our repository here. That's what I am talking about from class. So request type was new, concrete class, and passing the and that one. So okay, that's the same just only in your data access layer code. So first, what we modify is we add an interface here, this one, and just inherit a generic repository type interface. And after that, in the unit of work, we have a new signature of that interface, this one. And in the implementation of concrete class, in the unit of work, of course, we have to implement that changes in the interface. So we just have this public interface, a request type of that interface. And we will create the concrete class for that. This is the one. So once you create that concrete class, this one, no coding anymore. And then you can now have your controller or the API. So let's go to the controller. So from here, we will create a new controller. Go to API and API empty. And by this time, we will name it request type controller. Request type. So that is now our controller here. So first thing that we need to do, we have to have our constructor injection here. So this is to connect to our database, but we are not going to use the connection string, the context or DB context class, but we are going now to use the unit of work. That is why we have to inject here the unit of work. That's one. That's an interface, and we just name it OW, like something like that. And then of course we can assign a field property here. So that is why here, by naming convention, I also use the variable here as underscores. So I omit this. But anyway, either way it will work. So I have now injected the unit of work. So I will use now the unit of work in actually saving to our actual database. Alright. And of course our add, remove, which is in the memory, it's part of it. So first we are define our endpoint now. For example, we have to query first is certificate. Let's say for example we name this this is all right, and then our method public result. This is by default. Let's say for example our method name is only get, and that's it. And now we can just say or it's a variable the request or r type r double r is equal to unit of work, and then this is we added the signature request type of type uh, interface. When you say that request type, that you can have the add range, find async, get all. So we just get all. So this is in our repository get all. All right. So we see get all that one. Let's pass it all is here. Let's return. Okay. Return. Okay. And then the result. So you can see here, guys, it's just very little code. Okay. When you have to change your data logic, it's not here. It's all in our repository. So we debug from here. Just run and try it out. So I have here a request type. So request type, also double no. Okay. So try it out. So I will have to execute it. So you can now, it's firing now here. Okay, okay. So it's basically, there's no error. So you can see here that, okay, we can get the type. Okay, so that is how easy it is. That, for example, by ID, type ID. So basically we can just create this easily here. So let's try to create to add. So create another endpoint here. It's this add, so it's a TP FOSS. Okay, so we just have a name as add. So this one is just it's double also. So we have the controller request type, so that is now API that request type is controller. So we just put a list. This one we can have, yeah, maybe we can just add, and this is, you can either put this from body, uh, then a TPL request type model, and it just have the variable model here. Of course, yeah, request if model state is valid, so meaning is valid, then it's valid. So it will indicate whether any model state value is okay or not. So if it okay, then we can add. Else here we just have to return bad request. Let's say invalid properties, or there are some properties that are not correct. That, and then, well, if the model state is valid, so we can ask our unit to work that request type that will then, so it will add down in our memory, collection memory, but it will not actually save to our database, actual database. So we're gonna save it. We can just say unit of work that save a sync, like that. So if you want to make this synchronous, we can just add a sync here, and we can put this as task result, result, and from here we await. So this is more making our code more responsive, so it will not block any other request yet. Okay, so we try to debug from here, and let's run. Let's see if we can add to our table. So this is the one. So we just change the name to list and request type add. So click it, try it out. So we issue now. This is the model. So this one is, I don't know if this is identity. Let me check in our database. Request type. Side. It's not supporting the design. So stick type. So this is, for example, development. Let's start here. and it execute. Let's say it works. So we are now here in our code. Model is okay, and yeah, so it's now in a model. So you can see here the description is development type is 0, and when we actually save it in the database, oh, it's saving. What request? Invalid properties. So see, so okay, so maybe we should have valid properties. Let's try it again. Cancel it. Try to put an ID here, for example, 2 on development. Execute, and this time we just have to get actually having an error. I think this one is now successful. Server error. Saving the entity changes to exception cannot insert explicit value for identity column in table TBL request type when identity insert is set to O. Identity insert is set to O. It seems exception, so you can see here, guys. Let's try to look the problem here. Identity insert is set to O. TBL request type. Oh, identity insert. The problem is here. See the request. It's okay. If this is identity, oh, give a request ID here. This is wrong. This is not the foreign key. Foreign key. Delta request type. So there's no request type ID. Ah, okay, I know now. So I just need to update, guys. So let's go to our git package to create another add migration. Add migration that to let's take a look at server. Update database. Problem, I think all the data is gone. Just update the tables, table columns here. So quiz type should be 2 column only. I still have the TB quiz. here. This is to delete this migration folder. Let's build this first. It's here if our data model TBL request type is only 2. Alright, only 2. We'll create a migration again. And migration. Database. Let's manage the database. Now, it should fix it. Still 3. Delete this first. I know there's another way, but may I just delete it. You can remove the migration. I think it's delete your database. So now it's pressed. So we are doing. I just delete this and delete the database, and then it will create a new migration. Okay. And that's the wrong command. Uh, it's creating now a first database, guys. Yep, that's here. You can see in our table, we just see that request type should have 2 columns. What? We still have the TB request ID. Is this defined? It's not here already. TB request type. Okay, guys, I think it's adding now. So request type. Request type. So we're adding. So basically, I just remove the model checking first. We'll take a look at the issue later on because it's checking the model. The model is have a foreign key. Even if you see here the entities, it's just 2, but it's a foreign key connected to the table request. So that is why if you check the model state, it will be bad request invalid properties. So zero that is adding now. I just get rid of the checking of the model state. I think if you know the issue, please comment. For example, we type ID is, for example, team. Description here is development request, debrick, and execute it. We can get the data now. It's oh, yeah. I think we don't need to pass the type ID because this is identity insert. It will identity in SQL Server, it will add by itself. Okay, so okay, that's okay. I think that's the problem. Right, guys. So it's up just now. Respond body and we get in our SQL Server. It's now 3, right? So yeah, it's something like that, guys. It's basically what I am just showing you here is how to implement repository, generic repository pattern and unit of work in .NET 7 framework. And we're creating API in .NET 7. So controller this. Although there is a minimal API. So if you have not watched about minimal API, I have some video on that also. So I hope you learn a lot, guys, in implementing this generic repository and unit of work. So basically, uh, yeah, it's first it will be something that out of world. I mean to say, if you are not really familiar with, so because it will go to. But the easy step is just if you get used to this kind of uh, architecture is so easy. It's really dry, meaning don't repeat yourself. You, for example, is the one you need to work. If you have to create a new interface for a specific repository or entity, you just add here as an interface, a signature as interface type, and then when you implement the unit of work, basically it will have implementation here of type interface, and this is the name that you specify in the signature, and this is the implementation. And in our API controller, you can just initial, for example, we add requests. Yeah, that is the interface that we added there. Request type. Yeah. In the request type, this one, type controller. So you need to work on what implementation this request type, and then you can add. And lots of available method already there, and actually save the database. You have the save async that is in a unit of work already. So that's, guys. So please don't forget to subscribe and hit the bell button so you will be notified for the upcoming videos, upcoming tutorials that we will have. Okay. So happy learning, guys. Good evening. Bye bye.